Hello, everyone. My name is Asanul Chaudhary, and I'll be helping you to understand the basics of Python classes. Most of you might know about classes. Okay, so what's new about it? So what's new about it is that we'll be hands-on, and sometimes even if you're expert in object-oriented programming or classes, you'll probably not be using all these classes and syntax in your day-to-day life. So it's probably a good time for all of us to like brush up our classes knowledge. Also, it will be fun to code together. So there'll be hands-on exercise in every session, 15 minutes. And the first session we'll be doing the introduction to Python classes, and the second one is class constructors and initialization. So how do you construct classes? How do you initialize objects, and so on, right? And this is not going to be a one-way session where I talk and you just listen. It's going to be an interactive session. So feel free to stop me anytime when if you have a question. The session 3 will be understanding the basics of methods and inheritance, 20 minutes, and then we'll have an hands-on exercise. And the session 4 finally will be covering a little bit of encapsulation and access modifiers. Fifth session is basically a QA session. You're free to ask questions anytime, but the last session I kept it anyway, so in case you have something else to ask, so you can entertain that there. All right, let's move forward. Important links. I'm going to share these links with you. Session 1, Introduction to Python Classes. Before diving into the nitty-gritty details of Python classes, I think it's important to understand the pain point, right? Why do we need Python classes, first of all? There are so many things in computer programming language are complicated. Why Python classes, right? Why classes at all? So let's think about it. So let's think about a car. The moment we talk about a car, right, you may want to ask these 4 questions, very basic ones. What is the make of the car? Is it a BMW? Is it a Toyota? Is it a Ford, right? Many makes there. What is the model? It can be a BMW X5, for example. It can be a Toyota RAV4, right? Or it can be Ford Explorer, for example. And there are many others. Just a few to give you an example. Then the next question you might want to ask is that what is the manufacturing year? What is the color of the car? So these are basic questions that everyone would ask, right? But what if we want to create a logical car in Python? Create a logical car. When we say create a logical car, end of the day, using programming language, we can only build logic, right? We cannot really build a physical car using a computer. We need lots of engineering, like hardware involved to actually build a car. It's possible computer can dictate and eventually build cars, but from logic perspective, when we talk about programming language, we can build logical cars, right? So not the physical car we are talking about. So if we want to build a logical car in Python, it might look like this. So answering all these questions on the right side. So what we are doing is that we are declaring a variable, the car make equals Toyota, right? So I'm just saying that, hey, Python, I have a variable car make, car underscore make, that's the name of the variable, okay? And it's Toyota. Then car model is RAV4. Car year is 2020 and car color is red. It's basically just like a list of features, like it's saying the exact same thing on the left side, converted into Python code, right? Then I can just consider print car make, which is the variable that I declared, to just render Toyota, right? Very super duper basic elementary Python code. So I basically declared 4 variables to store 4 information, right? The make, model, year, and color. Excellent. So that's the super easy part. So this is not using Python classes. This is using Python variables, solving the same problem, right? Any questions so far from anyone? Now, well, introduction to Python continued. Great job. So we are done with the requirements. We wanted to represent all these 4 information in Python. So we just did that without Python classes. Let's go to the, so it's great job. And your manager is happy. And after 1 week, your manager says, hey, you know what? I'm happy with what you've written, but let's add 1 more car and change the first car's year to 2022. So now comes enhancement, right? When you write code, it starts simple. When we start coding, the code starts very simple. Gradually, it becomes complicated. It becomes complicated. There will be added requirement. There will be changes, right? So life is not always like you build one application and it will live forever. There will be new requirements. So your manager comes with new requirement. Add one more car. Okay. Then you asking the same question. Okay, new car, no problem. What's the make? Okay, this time is BMW. Model X5, 2021, and white color. So you got the requirement from your manager. And then you went back your Python file and you see that you already have the Toyota version there. Now you want to add BMW, so you start adding more variables, right? So now you see one problem. The first car was because your manager never told you there'd be more car coming in next week. So you just name the first variable as car make, car underscore make. Now you say, hey, I use car underscore make already, so I cannot reuse the same variable, right? So I need to create a new variable. So you name it like car2 underscore make. All right, makes sense. Car2 underscore make is BMW, car2 model, X5, year, and color. There you go. You're done. Excellent work. So what we have done so far, we added 2 cars information in our Python code, right? Successful, no problem. So far, it looks like 8 lines of code, and your friends, like your colleagues, everyone is okay with this code so far. Okay. Then comes the next requirement. After 2 weeks, your manager comes back again. I know it's getting boring, but that's how the reality is. So there's a new features getting added. After 2 weeks, says, hey, you know what? Add one more car, and this time it's Ford Explorer. And there you go. You did the same thing, and now you see your variables are just piling up, right? Car make, car model, car2 make, car2 model, car3 make, then car3 model. Well, it works. You are kind of keeping information in your Python file. That's okay, but is it really okay? Let's see what problem we have with this code, right? What problem we have this code. So before we go there, maybe I want to ask this question to everyone. Can someone identify the main problem with this code? Or a few problems, maybe. Few. Repetitive, yeah. It's not dry. Excellent. Dry. It's not scalable. Absolutely, it's not. So these are very, very, very important 3 information. Thank you so much. It's a repetitive code. And length of the code, see, yeah, you are adding more car and more variables are getting added. And then it's just creating more, lines of code in your file. Feels like why even write in Python? You could just take a pen and paper and just write in there. So it looks like it's no good. Doesn't look like smart coding, right? Violates first normal form. Yeah, yeah, yeah. Absolutely, absolutely. Length of code is pretty bad. Like, and also it's not scalable. Yeah. So great points. Thank you. So let's go ahead and see in the next slide. I mean, you just nailed it, right? I kind of say the same thing, but maybe just have 4 buckets, 4 main buckets. So it lacks organization and scalability, right? And Tammy just nailed it. It's not scalable, right? It lacks organization and scalability, making it very, very difficult to manage and maintain as you work, right? With more cars. Now it's repetitive code. Number 1, there is no data structure. The data looks like all the places. There's no clear structure to it. Only the structure, the only thing that you see is the car, and the car2 make and the car3 make looks like it's never ending, right? It's not scalable, right? And then limited organization. The structure of the data is hard to see at a glance. Like imagine you have 100 cars, right? How long will the file be? How do you organize all this information? But if you are in a, car selling company, you will not deal with 100 car. Maybe you'll be dealing with thousands, right? Thousands, and there'll be new cars coming, old cars going. It will be a nightmare to manage the cars. It's clearly not the way to go. Does it work? It might work for small scale, maybe for 5 or 10 cars, but it's not in the long run. This is definitely not the way to go. So here comes the solution. Okay, well, this is one solution. There are many other solutions, but today's topic is Python classes. So now we are introducing classes to solve the problem. Well, I don't want to claim that I solved the problem here because we haven't really. I claimed on the right side, you can see that it's grouped but not perfect. But let's see what we have done. So from the left side, we want to go the right side. Okay, so left side, what we have written so far, and on the right side, how it could have been written if we used classes. Okay, now you can see that we solved one problem. the variables were not grouped before. Now we kind of just grouped it, right? So we created a class. For grouping, we need a group name. So we grouped it. The first group is Toyota, okay? So it is, and how we group it is by giving a class keyword. Just think in that direction for now. I know this is not the right direction, but imagine a class is a group, okay? So I say class Toyota, which is group Toyota. Okay, group Toyota has a make, model, year, and color. Then I have a group BMW, make, model, year, and color. Great. So I have a Toyota group, I have a BMW group. Now, if I want to create, so these are groups. Now, if I want to create a member of the group, so imagine it's a Toyota group and I want to create a Toyota car, which is a member of Toyota. The syntax for doing that is just to declare the variable Toyota car equals Toyota. And there is this parenthesis. It just what happens here, what's happening here is that the moment we do that, it just creates an instance of that group, right? Or a member of that group. So Toyota car is becoming a member of Toyota group. That's it, right? Then I said that, hey, print Toyota car, and it says that, hey, the Toyota car is an object here. I'll explain that. This is because when we create an object, the object is stored in our RAM. The RAM has a location, which is a very long number. So it's been formatted in that way. What is important here is that what we have done so far, we have changed the flat file into a grouped file. It's a little better, but it's not the best. Okay. So let's code together. Any volunteer? Someone just copy pasted. Okay, that works. And okay, so you just say the class Toyota and you just pasted the make, model, blah, blah, blah. Okay. And class BMW. Okay. So we are creating another group called BMW. The run will not work now because someone is coding. There is no comma. Line number 8 doesn't require a comma, so you can remove that. Okay, it's gone. Yeah, good. Model. Okay, year 2021, and then let's do the color as well. Right now, if you run, let's run it. Okay, if you run it, and you can see, okay, there is a problem. Line number 1. What is the problem? It's standard in line number 2. Did we save? I think we didn't save. So let's stop and run it again. Okay, there is a run button at the top. There you go. We clicked on run and you can see that it says that main.toyota object at this. So someone was asking this question as well, that how this object at this, what does it really mean, right? So what it actually means that when we declared this Toyota car variable, right, equals Toyota, what the interpreter actually, Python interpreter, created a member that is of type Toyota, right? But where did it create the member? It did create the member. The object was actually created. The Toyota car was actually created. But where was it created? It's a logical object. It's not a real world object. It's a logical object. And the logical object is stored in our computer. Where? In the memory or RAM, right? It's stored in RAM. So when it is, and the RAM is huge, right? We have like 8 gig, 16 gig, 32 gig, like 64 gig is becoming a normal nowadays. We have a huge RAM, right? And when our computer stores the object in the RAM, it has certain location. It's important to know the location of it because when you store something, you want to retrieve that back as well, right? So when we say the print Toyota car, it actually says that, hey, I stored that in memory, and this is the location of memory. Okay, this is the location of the memory where the Toyota car object was created and stored. All right, now feel free to ask any question. If not, why don't we create a BMW object if someone can help with that? We have the Toyota object created already. Okay, so BMW cannot equal to BMW. It needs to be named differently because the class name is already BMW. So you might want to change it to something different. Just name it a different variable name. Give it a different variable name. And in Python, when you declare variables, it's better to do a small case with underscore. or it's also called snake case. Yeah, that works. BMW car. No, is the whoever is writing line number 16, you can't really pass the parameter because we don't have a constructor yet. Constructor is coming in the next session. So all you have to do, all you have to do is just call BMW function, BMW class, and then parentheses, and that's good enough. You could do that, but when you're starting, when you're trying to understand, when you're trying to initiate an object, it's important for everyone to know that when you construct an object, it actually gets stored in it's important that you store that in a variable. In an advanced case, you could do just like this. For example, I could just say print Toyota, right? And that would fly. Here is my new object, right? Here's my new object and Toyota. So if I just save it and rerun it, you'll see that I didn't really assign Toyota to a variable, right? But it would still work. Assigning to a variable is not needed, like Alex said. But since we are getting started with, I wanted to keep things simple. As you can see, here is my object, and then I have the direct object location, right? This works. Absolutely, this works. But this is a little more less verbose, right? Because people won't know, hey, you just call Toyota, I have the object, but you can't really do anything with the object. When you have an object, by the way, the benefit that you have, for example, here, Toyota car, and instead of printing the Toyota car, you can just say Toyota car dot make, right? So if you do that, and if you run it, then because we have the variable, yeah, mainly readability, and mainly for everyone to understand how to declare a variable and use that variable to do something and make it less complicated. But if you're doing a, say, see here, line number 16, when I say print Toyota car dot make, it printed Toyota, right? You can only do that if you have a handle to the object, right? If you have a handle, then you can go ahead and do this as well. So you can copy that and you can say instead of make, let's do model as well, right? Save that, to run it. Because we have a handle to this object, we can go ahead and print as many attributes as we want. It just makes it easy. But yeah, if you're in a team environment building professional application, yeah, you might want to pay attention to not add unnecessary new lines or declare unnecessary variables. Of course you can. You can do Toyota.make, right? But that's like I said, that's a little more advanced. But when you do that, if you do Toyota.make, for example, here, Toyota.make, and then again, if you want to print the model, Toyota.model, I hope this flies. Let's see. Oh, I need to save it. I don't know why it's taking super long. There you go. It says Toyota and RAV4. But there is a problem with this code, right? Who can tell me what the problem is in line number 16 and 17? It works. When I said Toyota.make and Toyota.model, it actually read the make and model and I just printed the make and model right in here. Can someone tell me what the problem is? Alex was saying that why can't we just, construct Toyota and just call the make? Yeah, it's not using the instance. That's true. But there is another. Yes, Paul, you are absolutely correct. It's creating two instances. It's creating two Toyota instances and it's creating two different objects and storing in the memory. So it's leaking memory, right? It's not the same object. And let's prove that, okay? Let's prove that. It's a very interesting point. Yeah, I know I'm going over time, but I think it's very, very interesting point. So let's do this. I remove the make from here and the model from here as well. So all I'm doing here, pay attention to line number 16. I'll remove the BMW for now, just to keep things simple. Paying attention to something different. All right, just save it. So what I'm doing here, line number 15, don't worry about that. So what I did, line number 17, print Toyota it's going to create a new object, and print Toyota again is going to create another new object, but it's going to also print the memory location of these two, right? So let's print and see what happens. I don't know why Replit is today a little slower. It used to be a little faster. I don't know. So there you go. So you see, all right, here it looks like it's pointing to the same memory location. It's probably a compiler. It's probably a compiler optimization. It's probably a compiler optimization. It only happened is because they're both pointing to the same object. So behind the scene compiler may be doing something. There's no compiler though. The interpreter may be doing something smart to change this, right? But it did create, end of the day, it did create two different objects. The moment I change the attribute, it will be different. So let's see this in action. So T1 is, say, Toyota, okay? And then I change T1 dot make to something different. So no, T1 dot year. So imagine we change it to 2021, okay? Then I create, let's create T2, and T2 is, let's change it to 2023. So now if I print T1 and then I print T2, because the member variables are different, they are bound to locate to two different addresses, right? So let's run it and prove. Okay, there you go. So you can see the first one is pointing to like 23B0. The second one is pointing to like 3E220. That did definitely two different memory location, right? But the first time when we tried, okay, so if I just comment this out, and if I comment the second one out as well, so we are not changing any data in the object, okay? We're just creating two instances and it's printing both instances. So let's see what happens. Okay, this time it didn't do the optimization. This time you can see that it's getting two different addresses. So that's an interesting behavior, okay? But I think it's very wise for everyone to understand that if you're calling the constructor, this is basically constructor or a constructor call that creates the object. It's supposed to create a different memory location every time it's called. So we need to be very careful, pay a little attention to our memory allocation so that we don't create unnecessary objects that can, end up in memory leaks, for example, or even bigger problems. All right. Any more question? Then before we move to the next session. All right. So let's move forward. This is so we know how to create classes now, and let's go to the next session. All right. So class construction and initialization. We already have created class. So we know that we created objects. So like a variable equals then Toyota, and it just creates the object. But the problem with the last one, if you see that we did group stuff, but we copied over data, right? You see that the class itself, it has the make hard-coded, the model hard-coded in here, year and color. Like, why do you wanna like create an instance of Toyota? And all the instances of Toyota will have the same RAV4. Is that really true? Different Toyota may have different model, different year, right? But the way we constructed the class here is not the best, because the moment we create an object, every object has the same data, which is definitely not something you want, right? So what we did basically is copy pasted this code, but this code is not the best. So instead, class should be used in a way that is basically nothing but a template or a blueprint, okay? The data should be passed to the class, and class should only be the template for creating objects, a template for creating object. For example, if you want a Toyota object, if you want a Toyota car, okay, you just create Toyota with the parameters, with the object values, and then it will create the object for you, okay? So what we had to do here, we introduced something called dunder init. Dunder init. Why dunder init? It's a built-in special function in Python that is used to construct a class. So whenever you call Toyota, this bracket, this function will get called. This is automatic. The moment you construct a Toyota object, this init will call. This underscore underscore init underscore underscore is something like a magic function, gets invoked every time you create an object. It's like a constructor in Java. Yes, Ronak. It's like exactly like a constructor in Java. Actually, it's the same thing. The only difference here is what did you call it? Is dunder init. Dunder init. Okay. It's underscore underscore init underscore underscore. The shortcut name is dunder init. So that's how Python community calls it, dunder init. Now, in the dunder init, we all know that whenever you create an object, this function will get called. Why would a function get called when you create an object? Okay, how does it deal with self parameter? Yeah, coming to that, Paul. That's a very important question. But it's very important important for us to understand the moment you construct an object, right? You construct, like you say, Toyota bracket, this init will get called. Question is, why should the init function get called when you're trying to instantiate an object? It's because so that you can do something about it. When the object is created, you want to do something, right? For example, when the object is created, you want to change the variable values to certain things so that it's prepared for the real world, right? Here, you can see the init function has something called self. This init function having self is something already built in. Like you must do that. You must do that. The self points to the object itself. The self points to the object itself. When you say self, it's actually the object itself. For example, if you create 1,000 Toyota objects, every self will point to an object itself. Self is, if someone has some Java background, self is the other name of this. Okay, self is the other name of this. So Paul is saying, how does it deal with the self parameter since it isn't used when, yes, it's because when this is just a placeholder. This is just a placeholder for the object that's going to be created. Okay, so that a programmer can use self to point to certain data. So here, when we say self, it's not really an object because there is no object, right? There is no object. I mean, surprisingly, in Python ecosystem, just everyone to know, for as a note, side note, in Python, classes themselves are objects. Classes themselves are objects, but this is a discussion for a different day, right? But as far as self here is concerned, these cells point to the object that will be created in the future. Okay, now when I say self.make means the object that will be created, that object's make is whatever make has been passed. So if you can see that the init has multiple variables. The self is a built-in one, so don't worry about that. We don't have to pass the self value. The compiler, sorry, the interpreter will automatically populate the self object on behalf of us. So don't worry about self. We just need to be aware that the self variable needs to be there and it will be taken care of by Python itself. Let's talk about the one that is more important to us. The next one, which is make. Make, model, year, and color. These are 4 variables to which we can pass values, which means when we create a Toyota object, we can pass the values through these variables. Okay, so there is no more hard-coded value. All right, when we pass this value, they're just a way to inject data, into the class, but they are not part of the class yet. They are just a way to send some data to communicate with the class. So we can pass make, model, year, and color as parameters. But in order to actually make them your own objects attribute, all we have to do is the self.make is making an instance variable for the object. Self.make is whatever value has been passed as make. Self.model is whatever value has been passed as model. Self.year and self.color, the same thing, right? So all the values that we are passing will then become a member variable of this object that is going to be created. Now, this is enough about the template. This is how the class will behave when values are passed in the init function. But how do we pass this value? There you go. Car1 equal Toyota. This is something we know already. We have just done that, right? But this time, in the parentheses, we are passing some extra value. Toyota is the first parameter, second parameter RAV4, 2020, red. So how many variables did we declare in the init? Self is 1, make is 2, model 3, year 4, and then color is 5. So 5 variables. But when we pass the values, we passed only 4. Toyota RAV4 2020 red. We didn't pass the value for self. It's because, like I said, it will be taken care of by Python itself. So we don't pass the value for self. We just pass the value for the custom variables that we created. Okay, so the Toyota is mapped to make, RAV4 is mapped to model, 2020 is mapped to year, and red is mapped to color. Here, no, I think I missed one point. So let's create a car1 equals Toyota and pass 4 values. And then the Toyota car1 becomes a Toyota car, and then I can just reference car1.make. That, and the car1.make is going to be Toyota because we just, the make has been set to self.make. So it's going to be printing Toyota for us. I want to reiterate on the fact that the this time we came from the setting, we instead of setting all the values, we use a template. The term template is very important. Your class should be, you should be thinking of a class as a template. The objects are basically the instance of the template. I give you one more example. You have a recipe for cooking something. The recipe is a class, but when you actually cook the dish, that's the object. The recipe tells you how to cook, how to cook the dish, right? The recipe is basically the template or the blueprint. But when you actually cook the dish, whether you create one dish from it or 10 dishes from it, right? Every dish is an object. So if you have 10 dishes, then you actually created 10 objects of the recipe or 10 objects of the recipe class. That could be one way of thinking. Another example that people give, I also like that. Imagine a template or a class is a blank form. Class is a blank form. Imagine you're applying for something, right? You're applying for something, and there are 10 fields that you need to fill up. The form itself is a template or a class, but the moment you fill it up, it becomes an object. You can make 10 copies of the same form, 10 copies, and then fill it, and 10% can fill it up with different information, which means that for the form class, you have now 10 instances. The moment you set the data, it becomes an object. So now we are gonna use the constructor to create the classes. So let's do that. So we need to modify this, and we want to create 2 classes, right? One is the Toyota class, the other one is the BMW class. Change it and use the dunder in it to initiate the classes. Volunteers, please. So Paul is asking, is init section the same as? Yes, the init section is the same as constructor in other languages, especially like Java. JavaScript, ECMA 6 also has classes nowadays, so it also has constructor if someone has JavaScript background. All right, I can see that we have the init function. Okay. Line number 2 is missing a colon at the end. So now we are creating template. Okay. So the first parameter is self, great. The second is make, model, year, color. Excellent. All right. Yes, we don't want to keep any data. We don't want to keep any data in the template or class. Normally, in most of the cases, data should be coming through the constructor, right? No problem. I have a question while volunteers are writing the code. If someone can answer, the question is, what is the difference between self.make and only make? So imagine self.color, right? Here, imagine I have a different, and imagine another variable. So make, model, color, and then there's something called transmission, right? Transmission is another kind of, what kind of is automated transmission? Is a manual transmission. So let me add a transmission, okay? And transmission is let me set it to auto, for example, for now. Okay. So can someone tell me that what is the difference between self.color and transmission variable in here? Paul is saying only makes only one copy of the class. Any instances of the class always reference to one class. Make. I didn't really get that though, Paul. Ronak is saying self variable belongs to the specific instance. Exactly, Ronak, you're correct. The moment we say self, we are basically pointing to the object, the specific object or a specific instance we are referring to. Transmission here is not a member variable. It's just a local variable, just a local Python variable. It has nothing to do with this object. is basically just declaring a variable in a function and nothing else. Thank you. So we got BMW, we got Toyota, great. So let's create the object. Okay, so I can see the Toyota car object has been created. Excellent. So let's print Toyota Toyota underscore car dot make. Let's see if it works. Someone is creating Toyota 1 T1. Okay. Okay. If you don't mind, I'll go ahead and delete all the code at the bottom. So hope no one is writing any code, and let's just run this code and see how it works. So keep it simple. So we have Toyota object and the BMW object. I misspelled that. Toyota car dot make, right? So let's go ahead, save it, and run it and see what happens. Oh, the execution is pretty slow. So you can see the Toyota was printed, which means we successfully created an object of type Toyota that has a make Toyota and model RAV4 2020, blah, blah, blah. Can someone create another Toyota object, but this time maybe a different model? Alex is asking, is there a global variable in Python? That's a very good question, Alex. There is no so-called global variable in Python. But I mean, it depends on what you mean by global variable. If you declare a variable at the top, it becomes a global variable. But by default, every Python file is a module. Unlike JavaScript. In JavaScript, imagine if you have like 5 JavaScript files, right? And then you just require all the JavaScript file in an HTML file. If you declare a variable anywhere in a global space, the variable will be available throughout the entire space, right? So in JavaScript, there is something called really global namespace. In Python, the chances are very low because every file itself is a Python module, and the scope for and whatever variable you declare in the file is kind of boxed for that file. Okay, so imagine you have file 1 and file 2. A variable that you declare in file 1 is not automatically available in file 2. You have to import that variable. Only then you get access to it. So yeah, that is so-called global variable, but it's not as bad as JavaScript. Absolutely, Larry. Give me one sec. I'll be sharing this with you. Share all the links again. There you go. All right, so we have another Toyota 4Runner 2023 and black. Okay, and then we are just printing the model. Okay, let's save that and let's try to run that and see what happens. Okay, so Toyota 4Runner, excellent, it worked. Awesome. So now you see that we are just playing with the data, right? The data is not hard coded. That's the beauty of it. Data is not hard coded. We're just using the template of different kind of Toyota cars, right? That's awesome. So we could also create a BMW and just finish this session. Maybe we haven't created a single object BMW. If someone can create a BMW object, then we can move to the next session. While a member is helping us with creating a BMW object, I want to ask this question. The question is, what do you think is the problem with class 1 and the Toyota class and BMW class? Can someone highlight the main problem? Same fields, exactly. Same fields, redundant. Don't repeat yourself. Someone rightly mentioned dry. Don't repeat yourself. This principle we have successfully violated that rule. So Toyota has make, model, year, color. BMW also has make, model, year, color. So is that really the best way to do that? I don't think so. And we'll be fixing that in the next session. Exactly, Paul. So we are going to fix that. And there you go. We have the BMW object ready. So BMW X5 2023 blue. And you can see that the model is being shown without a problem, X5. I have a question here. So the next session is going to be about inheritance, which is my favorite topic. So let's go there. But before I go there, I have one question. The question is, line number 19 and line number 22. Line number 19, the third parameter is 2020, which is a string type value. Line number 22, again, the third parameter is actually the year, but here is 2023, but it's a number, right? It's an integer. Line number 19 has 2020, which is string. Line number 22 has 2023, which is an integer. It's working. Python is not complaining. You are passing string, you're passing number, it's working. But the question is, why is it working? Yes, Alex, you're right. Loosely typed Python. Yes, Python is loosely typed. Or another way, maybe the better way to say, Python is dynamically typed. So if you make something a string, and if you assign a integer to that, it will automatically become an integer because it's dynamically typed, and the type can change at runtime. I'm not a big fan of it. Honestly, I'm not a big fan of it. If something is supposed to be string, it should remain string, right? And that can introduce all sort of problems. There is a Python principle. There is a Python principle. Explicit is better than implicit. Explicit is better than implicit. So I would like to be more explicit and make sure that it only accepts string, right? But here looks like it's like accepting all kind of values, and that's why class can help us. So instead of directly setting the value, we could use methods to set the value and do some kind of validation, right? So let's go ahead and do that. Paul has a question. Can we force types so we can reduce errors? We could actually. So you can do like this. So I don't want to get into this because today's basically a class on Python classes. So you could do this like str, okay? And when you do that, basically you're saying it's type hinting. You cannot force it though. Python will not yell at you, but by doing this, the moment you call, for example, Toyota, right? Toyota, and where's my autocomplete? Not showing the autocomplete. Okay, it's not showing the autocomplete, but when I say make is of type string, then what's happening is that you can see that make string str. So it tells the developer or your team member that, hey, for example, if Kim is the developer, Kim wrote this code and Kim wanted to make sure that you pass string only, right? So Python is still dynamically typed. Python doesn't want to change that because it's in the fundamental, but this just gives type hinting so that other folks know that actually it should be a string and not an integer. So we can catch the error early, at least help each other to write best code and eliminate some bugs. All right, so that's a good question, Paul. Let's go ahead and go to the third session. Okay, that's gonna be more, it's getting more interesting. Third session, methods and inheritance. Cami has a question. If you do that, do you need to pass the argument as? Not really. You don't have you don't have to change anything. Okay, when you do :str, you just did the type hinting here. When you pass the values, you don't have to do anything. I mean, it automatically maps to make anyway, right? You don't have to change anything here. It's just for hinting, nothing else. So it doesn't change how the parameters are passed. All right. Inheritance, methods and inheritance. We have so far seen how to add attributes and how to do construction, right? Using our constructor. Now let's talk about methods. What are the methods? When we talk about methods, we talk about actually doers, right? You built a car. Can someone say what a car can do? A car is an object. Imagine you become a car or I become a car. So okay, I'm a car now. What a car can do? A car can, anyone? Car can do what? What are the do thing that a car can do? No, a car, well, nowadays it can. A car can drive itself. A car can drive itself. Car can broom. I like that, Alex. Car can stop. A car can go. Yes, turn. So there are so many things that car can do. So methods are doers of the class. A honk, exactly, honk. So anything that the object can do necessarily will become methods, right? Anything that object can do will become methods end of the day, right? So that's basically it. So I added a method here, which is, you see that, oh, I missed the main point. I jumped to method. Maybe I should talk about the inheritance first. So see here, before we had on the left side, we had the class Toyota, and then we have class Ford. And the team has, everyone has it rightly identified. The problem is that we are repeating ourselves. Sell.make, sell.model, sell.year, and the same thing in the Ford as well, right? Same thing in BMW. So that's redundancy, right? We can do better. Instead of having Toyota and have all the fields in here, and Ford and having all the fields in here, we can have one class and name it a car, because Toyota is of type car. Toyota is a car. Ford is a car. In object-oriented programming, there are two kind of relationship. Everyone, I'd like everyone to very carefully listen to it. There are two kind of relationship between objects. There are two kind of relationship between objects. One is an easy relationship. For the first one is an easy relationship. The second one is has a relationship. Easy relationship end up in inheritance. Has a relationship ends up in having attributes. Okay? For example, a Toyota is a car. So because Toyota is a car, Toyota will inherit from car. Because Ford is a car, Ford will inherit from car. Ford is not Toyota. That's why Ford will not inherit from Toyota. Toyota is not Ford. So that's why Toyota will not inherit from Ford. Make sense? Then another, we could go one level up. Toyota is a car and car is a vehicle. Ford is a car and car is a vehicle. So we could say that vehicle is the superclass. Car could inherit from vehicle and Toyota can inherit from car. So you see the hierarchy, right? You see the hierarchy. So that's basically it. There's an easy relationship, there's a has relationship. We are talking about inheritance, which means we are talking about easy relationship. Can someone give me examples of more easy relationship between two different objects or classes? Because Toyota also makes trucks, so vehicle could be used. Yeah, absolutely correct. Absolutely correct. So we could have vehicle as a superclass, right? Then and car could extend from vehicle. Truck also could extend from vehicle, right? Fruits and apple. Absolutely, fruits. Fruit, apple extends or inherits from fruits because apple is a fruit, right? Apple is a fruit. Food, confectionery, chocolates. Yeah, that makes sense. Yeah, great. There you go. Easy relationship in object-oriented programming. Anything objects, when the objects have easy relationship, they will end up in inheritance. That's the bottom line of it. Okay, so I think we understand what inheritance is and why should classes inherit from each other, because they are simply, Toyota is a car, so Toyota should inherit from class inherit from a car class. And in order to make Toyota inherit from car, all we have to do is see this. If you see my mouse here, the big mouse, all we have to do class Toyota, then in bracket car, is the other way of saying that Toyota inherits from car, right? Then the Ford inherits from car. Just mention the superclass name and they are naturally inheriting from that class. Okay, as simple as that. Now, see, Toyota class has nothing in it. Pass means that it's done. Nothing inside of it. There is no further code in it. So it's just a blank class. Ford also has a blank class because they both inherit from, car. Everything that car has, Toyota also has everything. Everything that car has, Toyota automatically gets all the attribute, all the features. So you can imagine that all this code is also inside Toyota. All this car code is also inside Ford automatically, but it's done in a beautiful way, which is called inheritance. It's so powerful. It makes your code so manageable in the long run that the folks who are the folks who know like object-oriented programming, have worked in object-oriented programming paradigm, like they will know how much we appreciate the inheritance feature. I mean, it changed the entire world, how objects are objects relate to each other. It's a very beautiful way of creating object-oriented objects in computers. Now, because Toyota inherit from car, so as you can see, we are creating an object here, T1 equals Toyota, and just passing the attribute, right? Toyota RAV4 2020 red. And there you go, T1 is here. Then we can just call T1.getMake. Now, what is getMake? GetMake is a method that we declared here. See, a method or doer. I say getMake, do something, go and get the make of it, right? And then because it's a class method, self needs to be there. Self needs to be there, okay? You do get make, and then I return self.make, which is necessarily returning whatever is the make set in here, right? This is just a doer. You could directly access make, but it's the best way to do that is access the variables using attributes, using methods. That's the best way to do that. Okay, that will eliminate unnecessary, what do you call, unintentional modification to your your object data. When you use methods, that's the best way of talking to the class variables. Any questions so far? Paul has a question. Is getMake an arbitrary name you use, or is get underscore? It's an arbitrary name. Get has nothing to do with get underscore does not change the behavior of it. Okay. The reason I use get is because I know when you create a method, it should be a doer. So you just don't want to call it a make, because make is a name, right? Your methods should have some kind of doing action. That's why I just added get make. I could also say fetch make. Alex has a question. Is it better practice to separate superclass from their classes in a different file? It depends on how long your file is. In an ideal world, you don't want to complicate your code too much by adding too many lines of code. Okay. I personally would prefer a separate class if the class, if car.py is very, very crowded. Okay. Otherwise, I'll just keep in the same file. Sometimes creating too many files also create a lot of confusion. But if you're creating a library, that might make sense as well, Alex. So it depends on your use case. But in general, if you're like this small application, it might not matter. For example, in Django, the model, there are so many models you can create in the models.py, and then you just inherit the Django model and then use Django model as a superclass. So there, because the model.py can become complicated and there is a library, it's a better way to use the import the library model and then just use it. So yeah, if you're building something big, I think that makes a lot of sense. I love Django as well, Marcel. Django is my most favorite framework. It's a hidden gem. People talk about so many technologies. I think, if someone understands Django, he's like already a Superman in the full stack world. Alex is saying, once I learn how to read, I will tackle creating a library. Okay, awesome. Okay, great. So Alex is good. Libraries, you can just create every file in Python is a module. So you could keep all the superclasses in a module and then inherit from and import that module into other files. Marcel is saying, I recently learned it and haven't picked up Flask since. Yeah, I also started with Flask. It was pretty simple to start with, but then seeing the power that Django gives you, I never had to go back to Flask. All right, so I think we got the basics of methods and inheritance. If we don't do it, we'll forget. So let's go ahead and do it together. So let's go together. We add new attribute, okay? Add new attribute and new method. So let's do that. So someone already created the car. Maybe we can go a little far, right? Better than this. So instead of car, maybe we can just get a superclass vehicle, right? So let's create a vehicle superclass. Since we are already talking about it, I think it makes sense. Okay, so we have vehicle, and then in the vehicle we can have have our constructor. Just copy paste the constructor. Okay. In Python, the indentation should be like 4 spaces. Okay, but even if you give 2 is fine. But as a good Python developer, we should always make sure that there are 4 spaces in every tab, every indentation. Okay, and then we can just copy paste the attribute self.make and model. Yeah, there you go. Paste it. Excellent. The first one, go in. Excellent. Okay, and just add a tab for all the self.make. I'll go ahead and do that. There you go. All right, and then we have vehicle. A car is a vehicle, so a car can extend from vehicle, right? And then what is a special thing that car has that vehicle? A vehicle and car, the almost same thing, but the car has something that the vehicle doesn't. This is a very important point. Car has something that vehicle may not. Features, yeah. What are the features that a car may have, the vehicle may not? Just asking, just in case. That would become a little more interesting. Okay, so we have car, okay. Wouldn't a car have everything a vehicle? Yeah, I think let's not make it too complicated. Let's keep it vehicle, okay? So I think it's better for us. So let's make the second class. Sorry, I'll just modify a little. So then let's keep it as Toyota, okay? Keep it as Toyota, and we have BMW, and we don't need init. So I'm just helping a little. So in the Toyota, we can just say pass because we don't have nothing else to do because we already extend from vehicle, and we can also say pass. Now BMW is not inheriting from vehicle. So can someone fix it? Yeah, bracket, and then should. Excellent. So now both Toyota and BMW are extending from vehicle. Great. Final thing. We let's create 2 objects, one BMW and one Toyota. So I'll just get rid of that. Okay, Toyota is okay. We have 2 objects already, and if we just go ahead and run this, it should just work without a problem. Okay, now it's time to add features. Okay, it's time to add features, and it's time to add methods. So let's go ahead and add a method. Toyota, what is a method that you think Toyota should have, but BMW should not? Right? Both Toyota and BMW are extending vehicle make. Okay, the make. I think we have make covered, but from doers perspective, what do you think BMW can do that Toyota can't? Race. Okay. I know Toyota can race as well, but let's take race for now. Can someone add a race method in BMW? There is no function in Python. Is def, yes. Okay, def or define. Drift, yes, absolutely. So BMW can drift or race. So let's remove pass and add a new method in BMW. And the method name should be race, for example. Race. And because it's the class method, what is the first parameter that it should have? Self, right? You will have suppress can drift. Yes, absolutely, Marcel. There is no second parameter. So because we are not passing anything, we could definitely add a second parameter, but in this case, everything is just fine, right? We can just add self and then colon, hit enter, and then we can just print something, right? Print. I can help with that. I can help. Sorry, I can help with that. Yeah. So let's print. Okay. You're printing. So let's say I am drifting. I'm racing, or I'm drifting. Okay. Great. Why do we have def? Okay, line number 15, we have def because we are defining a method. Okay, method means the doers, right? A BMW can do something. So I can say, hey, BMW, go ahead and race, right? When you want to create a doer in a class, you just say the syntax for it is def. Like class keyword is for creating a class. Def is for creating or defining a method. Or is also called def is also used used for creating functions. When the function is inside a class, it's also called a method. When a function is inside a class, it's also called a method. Okay, so I see, thank you so much for doing that, but we can simplify that by adding double quotes surrounding. Okay, and then we don't need this anymore. All right, what do you think Toyota can do that BMW can? What is special to Toyota? Let's find a Toyota doer. Safe driving, more mileage. Okay, but how do you, save, we can say save, what do you call that? Is eco mode. Eco mode. Yeah, there you go. Themselves, right? Enable eco mode. Enable eco mode. And I can say here, print, I am in eco mode. All right, I'm drifting. Great, so you can see that we have two different classes. They have two different kind of methods. So let's go ahead and now Toyota car, can someone help call it? Someone help actually, can someone change the line number 23 and actually make the call to the enable eco mode and race? Toyota car, and the method that we have is enable eco mode, right? Toyota doesn't have race. We have race in BMW, right? So we can just say enable eco mode. Okay. Excellent. So we have enable eco mode. We don't have to print it because we are already printing in here. Or maybe we can just return from here, that's probably better. Don't print it. Let's not print it. We can just return the string of the text from there. Return. There you go. And now we can just say, yeah, enable eco mode. And for the BMW, we can just say BMW.race, right? BMW.race. Now, we created Toyota instance and says Toyota.enable eco mode. We create a BMW instance and set a BMW race. Okay, let's see what it says. All right, now Toyota says I am in eco mode, and BMW says I'm drifting. Well, the text doesn't really say who is saying what. So in order to fix it, how about we do this? Okay, how about we do this? We say dot make plus. Okay, just keep it simple. There is a better syntax. I don't like this syntax though. And then also here, self.make plus. So what I'm saying is that whenever you print it, I'm telling the car, whenever you print something that's I'm in eco mode or I'm drifting, also add the make so we know who is talking, right? So let's see. Toyota, I'm in eco mode, and BMW says I'm drifting. All right. Simple stuff, but very powerful stuff when understood well and when implemented correctly at work. Okay, any questions so far before we jump to the next section, which is encapsulation? The second question is that, why did I return this string? I returned this string so that I can print it here. So we are printing it here. We are printing it here, BMW. So if I run it, then nothing will be printed now. Nothing will be printed now. It's because we are not printing anything. You just returned it. Here I got the return value, but it wasn't printed. So I think it's a better idea to not print anything the method itself. Instead, just return the string, and that allows us to do something with it. So I can just say, hey, print whatever is returned from there. Also print whatever is returned from this method. Okay. So this is a little more organized, and you have better control in the code. So when you run it now, then whatever is returned from here will be printed. It just I find it better coding. It totally depends, Alex. So whether I would recommend Angular over React, it totally depends. If your team member is happy with React, I would rather tell you to stay with React. Okay. If your team member is willing to explore or take a new challenge, Angular might be a thing. Not every team is same. Teams are different. They have different preferences. They have different background. They have reasons to love one tool over the other, right? So there is, we can never say Angular is better than React, nor can we say React is better than Angular, right? So there are thought process, there are reasons behind choosing the tool. Tools are, and we should consider ourselves as software engineers. We should consider ourselves as software developers. Angular, React, Vue.js, Django, Flask, Express.js, all these are tools that we software engineers use to solve some kind of problem. So we should not become an Angular developer or should not become a React developer. We should become software engineers, right? And then use whatever tool is best for solving certain kind of problem. So let's proceed. Session 4. My favorite encapsulation. Actually, I'm like inheritance more. Encapsulation is also a very important, very important thing an access modifier because data hiding is important. Now, let's talk about encapsulation a little. What is encapsulation? When we talk about encapsulation, I talk about first thing I talk about is capsule. Okay, have you ever taken a capsule like a medicine? A capsule in which medicine, medicine resides inside of it, right? It's just a capsule. So when we eat the capsule, we take the medicine. We don't know what is inside of the capsule. We know that it's medicine, but we know exactly what it is. We don't really see. We just eat it and we know it works, right? Doctor gave us a capsule, we ate it, and it's gonna function. What is important to understand here is that we, as a patient, for example, don't need to understand what is inside of the capsule. What is important for me is to consume it so that it goes inside of me and works, right? That is encapsulation. I mean, what I'm trying to say here is that sometimes it's better for us to not know the details. Many times it's better for us to not know the details. What is important for us to get the job done? For example, if you are a good driver, you know how to drive the car. It's important for you to know how the car functions. Okay, important for you to know how to handle the car, be a good driver, but it's not important for you, it's not critical for you to understand how the engine works, how the braking system works. Without even knowing how the engine works, you will be okay, you'll be perfectly fine driving car safely. Is that right or wrong? Here, the car is encapsulating its engine's complexity in some way and giving you some interfaces like the steering, brake, acceleration, gear, all these tools. It's giving you all these tools that are important to you. It's not giving you a direct handle to the engine so that you can do something about the engine, right? Because you don't need it. What you need is the interfaces using which you can drive your car. Coming back to the object-oriented world or in the class, a class can do a lot of complex things. Today we are dealing with very simple classes, by the way, but this is how you start. You learn simple things and multiple simple things make it complex, right? So we are starting with something simple, but in real world, classes can be really complicated. So when you build a class, you build a solution, right? And maybe you build a class for 6 months, 1 year, 2 years, like multiple developers work to build a solution, build a class that works perfectly. Awesome work. But when a new developer comes and starts to work with this class or starts to use this class, it's not important for him to understand 100% how this class is supposed to work. What is important for him is to know how to create an object of the class, number one, and how to call methods and function to get certain things done. Okay, which means as a developer, it's not critical for you to understand every single detail of your application. It's better to not understand and overwhelm yourself, then focus on the deliverable, use the class, create the object, get the job done. Does that make sense? And this hiding of the data, this hiding of the complexity is named encapsulation. Okay, so when you design your class, if you think that the outside world should not interfere with some data, should not change some data, and you want to take control of it and not let people mess with it, use encapsulation, an access modifier to hide your data from the external world. Okay? Question so far? Okay, Sounds like it's very clear. So let's see how we implemented encapsulation and access modifier. First thing, access modifier. Yeah, let's talk about it. The access modifier here, you can see that, see the little difference here. Self dot underscore underscore make. Before it was only make. Now it's dunder make. Underscore underscore, the other name is dunder. Now it's dunder make. The moment you have two underscore, Python makes it a private attribute. Now this attribute is private. External world cannot change this. You can just pass the value during construction, and after that you are done, right? Once you set it, you cannot modify it without the permission of the class methods, for example, right? So you're hiding the data. You are just saying that I don't want people to mess with make data, right? You can get the make, you can set the make, but you can never directly set the make using attributes. And I'll show you what it means, okay? So if you have two underscore, it becomes private, point to be taken. Number two is self.underscore model. It means it's protected. The difference between private and protected is protected variable can be modified by the class that inherits it. So if car is inherited by Toyota, Toyota is okay to modify it. Okay, you can also directly access or modify model or protected attributes using objects, but it's not recommended. It's not recommended. You can do it. Python will not stop you, but it's not recommended. You should only do it when when a car is inherited by another class, and then let the class modify it instead of directly modifying it. Okay, so that's the protected attribute. The third one, as you can see, self.here is a public attribute. The moment you say self.something without any underscore or dunder, it means it's becoming a public attribute. So far, if I go back, all these attributes that we declared were public, right? Here, what we said, hey, you know what? Let's use encapsulation. Let's use, and in order to achieve encapsulation, we use access modifier. Underscore underscore make becomes private. Only one underscore become protected. No underscore becomes public. All right, so let's go to the next one. Now we made this private underscore underscore make a private attribute, right? Now, how do we access this then? In the OOP standard, in order to access your private variable, you have a method, getMake. And getMake is doing nothing but return self underscore underscore make. So that whoever wants to access make will go through this method, will go through this path, called the getMake function. Okay? If you have to modify the make for whatever reason, you cannot directly set the value for it. You have to call setMake and pass the make as a parameter and then set the make. See, there is a safety feature here. It is a safety feature. Whoever calls setMake to change the make, we have a feature here. If make is actually passed, if it is not null, or if it doesn't have a value, then don't bother changing. It will only change it if the make has a value. It's a safety feature, just to give you an example that what a setter can do, right? We are not exposing to public so that people cannot set it to null. Can you think of a car that does not have a make, right? Your class should not allow modifying the make directly because it's a private information and you don't want anyone to set a null value to it. That doesn't make sense, right? So this gives you an additional, safety, that whoever sets make will be making sure the method will make sure the make has a value. Next, protected method, def underscore repair. See, this method has an underscore. If the attribute has whether the attribute has underscore or the method has underscore, doesn't really matter. The moment there is one underscore, it becomes what? One underscore is for protected. This method also became protected. You can call it directly using an object, but it's not recommended. It's not recommended. Protected method should be used by normally an inherited class. For example, Toyota inheriting car, Toyota can go ahead and call the protected methods or change the protected attributes. Let's go to the next one, public method. Def start, right? Any method name that does not have underscore or dunder is what? Is public. Exactly the same way here. So whether it's an attribute or a method name, they work the same way. So this is public. The start method is public. The repair method is protected. Set make is a public method, but is for setting the make of a private member. Setting the value of a private member. Get make is a public method, is for getting the value of a private member. So this is how you get encapsulation, achieve encapsulation by using access modifier in Python. There is one more slide. I hope if there is a question, feel free to ask. But here is some examples. Now, when you create an object, right, you just go ahead and say my car equals car and just pass the values. You're done, right? But accessing a public attribute is very easy. You just call mycar.year, and let's go back. You can see year was public. So you can just go ahead and say mycar.year, and this will just work, right? Then accessing protected attribute, not recommended but possible. Okay, which means, like I said, you can say mycar._model. One underscore makes it a protected member. mycar.model. So you can do that, but it's not recommended. Okay, but it's okay if you inherited the class and then modify it, no problem. This is, you can achieve the, I mean, you shouldn't do that because it's not recommended, right? You want to be a better developer. You don't want your colleague to question you that, hey, you know what, this is a protected member. Like, yes, it works, but should you be doing that, right? So it's like not a very good discussion. Let's go to the next one. Accessing a private attribute using a public method. So now we want to get the make. Now, if you remember, the make was a dunder make. Dunder make is a private attribute. You cannot directly say my car dot underscore make because that is private. So in order to access make, the only way to get the value is called the method get make. That is the only way to do that because we made it a private member. Let's go to the next one. Set make. Now we, for whatever reason, we decided this is the session 4. The section, not session 4. It's a section 4. It's a section 4. Sorry, I should have changed that. All right. So now, when we started, we said the car model was sorry. The make was Toyota. Now we want to change it to Honda for whatever reason, right? So my car set make Honda. Okay, that's the only way to access or modify the private member. Okay, and then you can do again get make to get the value from it. Next, access protected method mycar._repair. You can do that, yeah, but better if you don't. Accessing public method, no problem. mycar.start. It will just go ahead and start the car. Okay, so in a nutshell, you have a dunder syntax making it private, one underscore making it protected. And if something is private, you need custom methods to set the value and get the value. I mean, it's difficult to understand encapsulation if you don't do practical. So let's work together and do it. Okay. So let's achieve encapsulation. So this time I will code. Let me code. So we have vehicle. I can actually copy it just to make things faster. Almost 10 o'clock. So let me copy this. We don't have to actually. So we can just say, let's change the make to private. So this becomes what? Private. And let's make it protected. And we all know, we just learned that if you do one underscore, it becomes protected. So we'll keep things simple for now, okay? And then we have Toyota and we have BMW. I want to stop here and ask you one question. The moment I changed underscore make, change the variable, you see it's highlighted here as this is not accessible. So I said, let me change that. Underscore make and underscore make, okay? So let me run this and see what happens. Sure, the recording will be uploaded. The recording will be uploaded, okay, in the YouTube channel. I shared the link. Hope you got the link. If you didn't, just let me know. So if you see, I just changed the make and model. Sorry, I just changed the make to private and model to protected, and then we have an error. Toyota object just has no attribute called underscore Toyota underscore make. Where is it? Line number 17. Can someone tell me why this is happening? It says that Toyota object can access make for some reason. Yes, absolutely, Paul. That's the first thing. It's private now. Private means if this private to this vehicle class, this is private to the vehicle class. So outside of vehicle, this make does not exist, right? So you decided, for whatever reason, you decided that I want to make the make of the car private. So I cannot really directly access this anymore, okay? For whatever reason, right? So now in order to access that, what do we need in order to access private? In order to modify a private variable, we need methods, right? Method is a way, or a method is a way that allows us to expose an interface for outside world to set a value for the private variable, okay? So in order to do that, so now since we blocked ourselves, well, everyone understands why make is not available in Toyota and BMW? Everyone understands why make is no longer working? Great. So now make is not working because it's private, right? So let's solve the problem. Because it's private, we can solve the problem by exposing a public method, right? So def set underscore make. Set underscore make. And set underscore make is a public method. The first variable will be self. Let's set first, and then we can do get. Let's do get. Okay, let's do get. Let's keep things simple. Def get make. Okay, and then we have the self. That is the first parameter. And in order to return the make, we just return self, the current object, the object itself, underscore. I see that underscore make is auto completing. Excellent, right? And here in Toyota, now we have a way to access make. We just need to, someone has to just call the get make function, our method, right? So in here, instead of calling self underscore make, we just do self dot get make, right? Also self dot here get make. Okay, so this way now I exposed a private variable to the outside world, but using a method only. Okay, so let's run it. It's working. It's working. Okay, so great work. It's working. So let's do one more thing. So we understood the private part of it, and private means that it's private to this class. Even the class that is extending it did not have access to the make variable. So we had to actually create a method to expose it, right? So let's go ahead and play with the model variable. Okay, so instead of like we said here, the self.get make, let's add make. Let's get the self.get model as well. Okay, make and model. See, it's becoming more complicated now. Self.get model. Oh, we don't have get model. So why am I calling get model? Sorry, it's self underscore model, right? Underscore. See, the moment I said, see, I'm in Toyota, right? The underscore model is declared in vehicle, but the moment I said underscore, the model is showing up. So there you go. So let's copy that and try to access that in the next one as well. Okay, let's paste it and plus. All right. Oh, right, double plus. So let me run that. There you go. And I hope everything will work. And everything will work because, and you can see the Toyota RAV4 and BMW X5. We have access to X5. We still have access to RAV4, which is the model value directly. We didn't have to actually, create a method to access it because it's protected. A protected member is open for inheritance. A protected member is open for inheritance. So this Toyota class inherited vehicle, so the protected member directly became as if its own member, so I could directly access it. Not only can I access it, I can also modify it, right? Because I can read, I can also write to it. So there is no restriction. A protected member is exposed to the class that is that inherited it. So Toyota, that's why I can access it. BMW can access it. Okay. Paul has a question. Then what is the difference between public and protected? Yes, that's a good question. In Python, Python does not force you. For example, let me change it here. So see here, I'm changing in line number 30. Okay, so I'll take the Toyota car, and then I will say Toyota car dot. Let me change the color. Okay, let me change the color to. It was red. I'll change it to white. Do you think there will be any problem? I'm changing the Toyota car's color to white. Do you have any objection? Do you think there will be a problem? There will be no problem because color is public, right? And neither is protected nor is private. Color is public, so I have no problem. So let's go ahead now, change the Toyota car dot underscore model. Okay, no, let's change make. Underscore underscore make equals, and let's change the make to Honda. Okay, and let's try to run it. What do you think will happen? I'm trying to change the make, which is a private variable. There will be an error. Did it even get executed? Okay, I did the make, but this changed nothing. There is no error. I think I should have clarified that. Let me do Toyota dot get make. Okay, so I'll print Toyota dot get make. Okay, let me do that. And I changed the look like in line number 31. I changed the make to Honda. The make was Toyota, by the way. Then I got I'm calling get make. Okay, let me run that. What do you expect will happen? Toyota is still RAV4. Let me see. Sorry, get make. When I printed the get make, what did I see? It's still Toyota. It did not change it. It did not change it, which means this had no effect. This had no effect on this private variable. So this didn't throw an exception, but did it work? No. So you can't really change the private variable. But let's change something else. So I know make, so we all can prove that changing the make will not work. It's private. So let's change the model now. And the model, let's change to, for example, Camry. I hope I spelled it correct. Okay, and then underscore model. So let's do that and let's run it. See, it changed to Camry, but it's recommended. It's recommended that you don't touch protected variables directly like this. It's recommended. Python will not stop you from doing that, but this is bad practice. You crossed a line. Okay, so as a quality Python developer, right? You want to conform to the law, and you don't want to break the law like this. Even if you can, no one can. The Python is not stopping you, but your team members will not like it. Or if you're contributing to open source community, they will not like it because you are breaking a rule here. Okay, just because you can do it doesn't mean it's right. Right? It's 1 minute over, but still. Oh, I'm open for question. So any question, please. Thank you so much, everyone, and hope to see you in the next class.